Alright, this is activity 21 of our geometric sequences. In this section, you're going to identify exactly what a geometric sequence is and the common ratio for a geometric sequence, and then distinguish the difference between arithmetic and geometric. So before we get into geometric, I just kind of wanted to do a reminder of what an arithmetic sequence was. That's where you can say you're basically adding or subtracting a constant term each time, and we call that the common difference with the letter D. So if you had a sequence that was 2, 4, 6, 8, that you can easily see that you are adding 2 each time. So that common difference would be D equals 2. Geometric is a little different in that we're not adding, subtracting each time. So we're going to start by talking with Keisha. She wants to investigate social media and decides to post a video to see if she can make it go viral. So to get things started, in stage 1, she sends it off. So one person has the video, and that's just Keisha. But the way it works is she sends it to 3 friends. So now we're in stage 2, which means 3 different people have seen the video. And then each one of those 3 friends is also going to send it to another 3 friends. And then in turn, each of those 3 are going to send it to 3 of their friends who have not seen it before. So you can see how easily the numbers jump up into the number of people who have seen it, and we're only on stage 4. So filling in the table, stage 1, it was one person, that was Keisha. She sent it to 3 of her friends, so that would be stage 2. In stage 3, each one of those 3 friends sent it to 3 more people, so now 9 people have seen it. And then each one of those 9 people sent it to 3 more, so now we're up to 27. So question number 2 says, describe any patterns that you notice. Well, if you kind of look at the numbers, you can kind of see a pattern of multiplying by 3. So each stage is getting multiplied by 3 because every person that sees it sends it to 3 of their friends who have not seen it before. So this is the idea behind a geometric sequence. The number of people who receive the video at each stage form a geometric sequence. A geometric sequence is a sequence of values in which a non-zero constant ratio exists between consecutive terms. The constant ratio is called the common ratio, and it's typically denoted by the letter R. So with arithmetic, we call it the common difference. With geometric, we call it the common ratio, and they use that letter R instead of letter D. It's what you're multiplying by each time to get to the next number. So 6 says, write the number of people who have received the video as a sequence. So we started with Keisha. She sent it to 3 more. Then 9 people saw it, and then they sent it off to 3 of their friends, which means we had 27. So then looking at that, we know we are multiplying by 3 each time. So identify our common ratio, we can say that R equals 3. The next section really just kind of has you identify the difference between arithmetic and geometric. Remember, arithmetic you add, geometric you multiply, and then neither one of those things. Also remember, arithmetic adding can be adding a negative. Geometric can be multiplying by a fraction or a decimal as well. It doesn't have to be, or a negative number. And it says if it's arithmetic, state that common difference. So we're going to say that's that D equals. If it's geometric, the common ratio, that's the R equals. So looking at A, to get from 5 to 8, that means I add 3. Well, 8 to 11 is still adding 3. 11 to 14 is still adding 3. So because I'm adding, that is an arithmetic sequence. And our common difference is D equals 3. For B, if you notice, the numbers are going down. And you can kind of tell like 18 to 6 is a big jump and 6 to 2 is not really that big a jump. So it's probably not arithmetic. But what I do know is if I look at from 18 to 6, I can multiply by 1/3 and get 6. And then if I do 6 times 1/3 again, I get 2. And then to get 2/3, I multiply by another 1/3. So this one is going to be geometric. And so we're going to say R equals this time r equals 1/3. If you're not really sure, what you can do is look at your second term and divide it by the first term. So I can take 6 and divide it by 18 and simplify, and that gives you 1/3. So you can also get your common ratio that way if it's not obvious just by looking at it. Looking at C, so between 1 and 4, it would make sense that would probably add 3. 4 to 9 is add 5. But you can see since they're already not the same number, and I can't multiply 4 by anything to get 9, so we're just going to go ahead and say that that one is neither. If you look at D and E, one thing you'll notice is that you have negative and positive numbers that are alternating. That is usually a good sign that it's probably going to be geometric. That's usually not going to be arithmetic, because if it would either stay positive or stay negative depending on what your common difference was. So look at geometric first, and if geometric doesn't work out, then it's probably neither. So if I have -1, I want to get +4. That means I need to multiply by a -4. Well, if I do 4 times another -4, that gives me -16. -16 times -4 gives you +64. So this one's going to be geometric with a common ratio of -4. So same thing with E. They're alternating between positive and negative. So I would definitely try geometric first. And you can kind of easily see these numbers are pretty much getting cut in half, which means I'm multiplying by a -1/2 each time. But if it's not completely obvious, remember you take the second term and divide it by the first term. So if I do -8 divided by 16, you get -1/2. So this one's going to be geometric with a common ratio of r equals -1/2. And that is pretty much it for 21.1. Now I'm going to go to 21.2. And in this one, still talking about geometric, so we're going to learn what to write, what a recursive formula is for a geometric sequence, write an explicit formula for a geometric sequence, and then use a formula to find a given term of a geometric sequence. So still keeping the idea that you're multiplying each time, we're just going to talk about the different formulas that you use and how you can find those pieces. So looking at number 1, remember that numbers in a sequence are called terms. So every, term 1, term 2, term 3, that's just the number in the sequence. And they do that by notation a of n, or f of n if you're in terms of function notation. So a1, or what you would see as f of 1, would be considered your first term. And in this case, still talking about Keisha in the video, that was 1. So I'm going to write that sequence up here. We had 1, 3, 9, 27. So think of this as stage 1, this was stage 2, stage 3, and then stage 4. So at stage 2, or f of 2 if you're in function notation, we had 3. Stage 3, so a sub 3 or f of 3, we had 9. And then a4, f of 4, there's 27. We said our common ratio was 3. So part B, what is the value of the following term a of 4 equals 4? Write an expression to represent this term using a4 and the common ratio. So basically what they're saying is they want us to write an expression to represent this fourth term, which we know involves this one. So anytime we have it, we're taking that a sub 4, which is our fourth term, we're going to take it and we're going to multiply it by 3, because that's what we do each time, which a sub 4 is 27. So 3 times 27 would give us 81. What this is called is the recursive formula. What it does is basically recursive just wants you to see where you start at and what you're doing each time. So like on number 3, the recursive formula for the viral video are partially given. So you always have to list the first term because you have to know where to start. And then what you're doing each time. Well, I'm taking each previous term, which we say is n minus 1. Oops, sorry. And I am multiplying it by 3. And it would be the same thing if you were in function notation. I'm just taking the previous term, which is f of n minus 1, and multiplying it by 3. So all you have to write for recursive are these two things, where you start, so what your first term is, and then basically using that r value with times your previous term, which we denote as that a n minus 1. Okay, so I'm going to jump to down here to number 9. That was the recursive formula. What we use a lot more tends to be the explicit formula. And the way the explicit formula comes about is looking at what your exponent does each time. So for the viral video sequence, identify A1 and R, then fill in the missing blank. So A1 we know is 1. We said our common ratio was 3. So to get A2, taking 1 and multiplying it by 3 just once. That's how I get 3 people that have seen it. For my third term, I'm taking it and multiplying that by 3 again, which means I've multiplied by 3 once. Multiplying by 3 again, which means I've now multiplied by 3 twice. And that's how I get 9. So you see my exponent just went up by 1. So then I'm going to multiply again by 3, which means I've now multiplied by 3 times. And that's how we got 27. So for the fourth one, I'm going to multiply by 3 4 times, which gives us 81. 1 times 3 to the 5th is 243. And then see here how it says it jumps to the 10th. Well, if you look at here, all I'm doing is going up on my exponents by 1. But if you look at my stage number and my exponent number, it's 1 less. See that I have 3 here, but I only use 2 here. I have 4 here, but I only use 3 here. So if I have a sub 10, that means I'm only multiplying by 3 9 times, which gives a total of 19,683. So, looking at number 11, the explicit formula for the viral video sequence is a sub n equals, we know we're starting with our first term, and we're multiplying by 3, and then our exponent is always 1 less than our term number, so since it's 1 less, we denote that as n minus 1. So your explicit formula, kind of went backwards a little bit, your explicit formula for a geometric sequence is a sub n equals, you always have your first term times your common ratio, and then n minus 1, because it's 1 less than the term number that you are on. Now it also wants us to find the 12th term of the sequence. So what that means is n equals 12. So I just say a sub 12 equals 1 times 3 to the 12 minus 1. So all you're doing is everywhere you see an n, you're plugging in that value they tell you to of 12. And what that gives you is 177,147. So that's what the 12th term would be. So a sub 12 equals 177,147. Okay. So looking at number 13, given a sequence 5, 10, 20, 40. Basically, you can see it tells you it's geometric, so you know you're multiplying. So times 2, times 2, times 2. So write an explicit formula. So remember, you just need A1 and your R. So your formula would be A sub n equals 5 times 2 to the n minus 1. And then if you wanted to find the 16th term, that's just a of 16 equals 5 times 2 to the 16 minus 1, which would give you a value of 163,840.